Hello and welcome. My name is Ms. D, and we're here to talk about shield metal arc equipment setup and operation. Let's keep going here. All right, so we should be able to understand the process of shield metal arc welding, SMAW, how to measure current, how adding chemicals to the electrodes can affect them, and understand what open circuit voltage and arc voltage or operating voltage is. What generators and alternators do and how they compare, what a rectifier does, what is duty cycle, how to ground, and of course, where to put your welding machine. So here are some key terms that we're going to talk about. Amperage, duty cycle, inverter, open circuit voltage, wattage, voltage, welding cables, and welding leads. Some of the terms, SMAW is a welding process that uses a flux cored metal electrode. An electrode is something that carries the electrical current. Some electrodes are made into the weld, others are not. SMAW uses a consumable electrode, means it gets used and made into the weld. So the electrode carries the electrical current. When the electrode is struck against the metal, it creates an arc. The gap between the electrode and the work is called arc length. The arc length should be equal to the diameter of the electrode rod you're using. For example, industry standard is 1/8 inch diameter rod, so the arc length should be about 1/8 inch. The arc then melts the flux or chemical covering on the electrode. It also melts the filler metal inside the electrode and the base metal. The flux creates a gaseous cloud that protects the weld pool while it is still molten hot. A slag covering is created from the impurities in the metal and is chipped off after the weld is completed. SMAW is widely used because it has a low cost for the machine. It's flexible, portable, and very versatile. SMAW process can be used on many different types of materials, thicknesses, and positions for different joints. The most common joint designs are butt, lap, corner, T, and edge. The most common type of metal to be welded is mild steel, otherwise called ASTM A36. Other materials can also be welded with just a change in type of electrode rod. Metals can be just about any thickness from 16 gauge to several inches thick. 16 gauge is about 0.060 or 60 thousandths. And the tools below are used, these ones right here, they're used to find the thickness of material if you're not too sure about it. Okay. SMAW can be done in all positions, meaning flat, horizontal, vertical up, vertical down, and overhead. Some welding processes can only be done in particular positions. So when we speak about welding positions, we're talking about the direction of your electrode and not your weldment. If you need some clarification, please visit the video library and watch the video Welding Stuff You Need to Know. Okay, so we need to understand some electrical current, okay? Because this is where our source of heat comes from, okay? Remember, current is the flow of electrons. I made sure it was in red too. Current is the flow of electrons, okay? Electrons can flow through a conductive source from negative to positive. A conductive source would be like metal or a cable. Resistance is the flow of electrons that produce heat. Remember, it is defined as the measure of the opposition to current. Resistance is measured in ohms, and the symbol is the Greek letter omega. Okay, the flowing electrons across an air gap produce an arc. So here's omega, this is the omega, okay, and resistance is measured in ohms. Makes sense? I hope so. All right, electrical measurement. There are 3 units that describe electrical current: voltage, amperage, and wattage. The first one is amperage, or capital A. Andre Ampere was a scientist who worked with electromagnetism from 1700 to 1800. An ampere or amperage is defined as the amount of electricity flowing through a circuit. To get more descriptive, 1 ampere is defined as 1 coulomb of electricity flowing past a particular point in 1 second. Think of amperage like flowing water. Amperage controls the size of the arc and the heat that is associated with it. All right, voltage is next. Voltage is represented by the capital V and sometimes capital E, depending. So the unit of measurement is a volt because science. Because electrons and protons have opposite charges, they attract to each other, kind of like north and south pole of two magnets, okay? So when the charges are separate, it causes a force or pressure between the charges. This force is voltage. Voltage can be considered the speed of the electron traffic. In other words, voltage is the force that makes the current move. Wattage is last, okay? And let's look at wattage. Okay, we're still on wattage. Okay, so wattage is last. Wattage is represented by the capital W. A watt is the basic unit of electrical power. Wattage is measured of electrical power that is expressed in, what is it? Watts. It is the operating power of an electrical device that is expressed in watts. So to summarize, current or amperage is the amount or volume of electron traffic that is flowing. Voltage can be thought of the speed of the electron traffic. And if we need to find wattage, we say the amps times the volts equals watts. Okay, so there's your electrical deal for the day. Okay, so some of the information on the next couple of slides can be confusing. So temperature is the degree of level of thermal energy in a material. We can't measure temperature in degrees with, we can measure temperature in degrees with a thermometer. Heat is how much or a quantity of thermal energy. This is difficult to measure. So we know to a certain degree temperature and heat affect each other, but they can also change independently. So, for example, the small red hot spark from a grinder and a red hot weld are both the same temperature, but the weld has more heat. Why? Well, the quantity of the heat in a material is a function of both its temperature and its mass. Another example would be a match and a bonfire. Both are burning at the same temperature, but the burning match does not produce the same quantity of heat like a bonfire. Okay, so the temperature of the arc from both a small diameter electrode and a large diameter electrode is the same, but the larger arc has more heat. So the bigger it is, the more it is. Okay, the arc temperature for SMAW can range around 5,500 degrees Fahrenheit to above 36,000 Fahrenheit. Most SMAW welding arcs on average have an effective temperature around 11,000 degrees on average. The voltage and arc length are closely related because as the arc length increases, the resistance increases. So it takes more voltage or more pressure to keep the electrons flowing across the gap. So the shorter the arc, the lower the resistance, lowering the voltage and lowering the temperature produced. As the arc lengthens, resistance increases and causes a rise in voltage and temperature. Okay, so most shield metal arc welding electrodes have flux coatings. These coatings have special chemicals added to stabilize the arc. And if you guys are really interested in this, please come see me, and I have some really cool stuff for you guys to play with in regards to flux coatings. So these stabilizers form gases or vapors to make the arc more stable and reduce the resistance. So it makes it easier to keep an arc going. So by lowering the resistance, the arc stabilizes and also lowers the temperature of the arc. Changing the chemicals in the flux can cause changes within the gaseous cloud and the arc itself. So these changes may raise or lower the temperature and the resistance, depending on what it is. All right, SMAW welding arc heat. So the amount of heat produced by the arc is determined by amperage. So when I say what is your heat, we're talking about amperage. The higher the amperage setting, the higher the heat. The lower the amperage setting, the lower the heat. So each diameter electrode has a recommended minimum and maximum, and we'll talk about that later. So not all of the heat produced by an arc reaches the weld. Some of it is dissipated and radiated away in form of light as well as heat. So some additional heat is also carried away with the hot gases. Okay? Heat is also lost through conduction in the work. So it goes into the work and disperses. So about 50% of all the heat produced by the arc is missing from the weld. Okay? The remaining 50% the arc produces is not distributed evenly. So it doesn't go to one side or the other. The distribution depends on the composition of the electrode's coating and the type of welding current. All right, guys, so this is part 1. We will have a couple of different parts and not to overwhelm you, but as always, weld the world.
Weld the world.